We have work classes, and I post all the recordings there, and the past papers, and the syllabus, and everything like that. So, hold on, I feel. These are your objectives. This is what you're required to know for your exam. We did everything here except, well, actually, no, we did everything here. But I just have one thing to show you again, right? So yeah, we did all this. The people who weren't here, we did this. All the identities we need to know. The uses of trig identities, how to prove prove other identities. Hold on, people are joining. Quadrant solving. We did these examples last class. This is the last thing I need to show you. This, we just show you exactly what we're doing. What you just saw is a use of the trig identity. So what trig identity? So these are the trig identities that you have to know. The Pythagorean, tan theta, addition formulae, double angle formulae. Those are the identities that you're required to know for your exam. But we can use those identities to do other things. We did last class using the identities that we know. So all that I went through just now, Pythagorean, tan theta, addition formulae, double angle formulae, also known as multiple angle formulae. We can use it to prove other identities. We did that already. To put a trig equation into a form so that it can be solved. We did that already. This is the last one you need to know how to do. We can use the trig identities that we know to find the exact values of trig ratios. So what exactly do I mean by that? Well, doing an example with you, I feel like that would be the best way for you to understand what's going on. So can you just copy this for me? Like the question here, and then part A. We'll do part A together. We'll do part B together as well, and then I'll let you try part C later. But for now, just copy this and part A. Let me know when you finish.
Miss, I got it down.
Is everybody else finished? If not, I'll wait. Okay, everybody finished with that now? Yes, no?
Not yet, miss.
No? Okay. Let me know when you finish.
Miss. Miss, finish the copying down or the solving the actual problem itself?
Copy it down. I didn't show you yet.
Easy.
So you finished with that?
Miss, I copied it down.
Yeah,
Okay.
me too.
So is there anybody still writing? Going once. Going twice. All right. So let's see. If I see a question like this in my exam, what exactly do I do? So they told you that sine A this thing is still not working. Anyways, bear with me. Sine A is equal to what? Minus 8 and 17. And they told you that there's a range. A is greater than 180 but less than 270, right? And they also told you that cosine, right? Why is this thing? Why is this thing trouble? Cosine of, hold on. Let me try to fix it. Cosine of B is equal to minus 5 on 13. They also gave you a range for B. They said that B is greater than 90 but less than 180. So what exactly is the significance of that range? Well, we'll see that just now, right? So the first thing I want you to find, cosine of A minus B. Cosine of A minus B. So based on what we did previously, this first part right here should be relatively easy. Why? Because this right here, cosine of A minus B, we know this identity. This is one of our, this is an addition formula from the trig identities that you're required to know. So it was on the PowerPoint, right? Anybody who was with me or who knows? Cosine of A minus B, that's the same as what expression? Does anybody remember?
Cosine A times cosine B minus sine A plus sine B. I mean, by sine B.
Close.
No,
It's,
plus or minus, no, minus plus. If it's minus. If it's minus on the right side of the
Plus minus.
yeah, plus minus, no, it's minus. It'll be minus plus, but the sine rule is plus minus.
So if this is a minus sign here, what sign am I putting here? Minus or plus?
Plus is the opposite of what is on the right side of the equation sign.
Good job. And then sine A times sine B. So that is relatively easy, right? Why? Because you're supposed to know that. So if they wanted me to find the value of this, so without a calculator, so I can't just plug in these values into here and, you know, whatever. They said without a calculator, right? I have sine A, I have cos B. So let me just write that out. So looking at this expression right here, right? The right-hand side. I have cos B. I don't have cos A. So that's cos A times cos B, which they gave me as this. So let me just put this in brackets. 5, 115. Plus sine A. I do have sine A. By cos B. No, let me cos B now. Sine B. I don't have sine B. There's a problem. If I want to find the exact value of this, I need to know all of these values. The thing is though, I only know what sine A is and I only know what cos B is. I don't know the value of cos A and I don't know the value of cos B. So we need to find out the value of this trig function and this trig function. How exactly do we do that? So this is how these type of questions are different from the others. So how exactly are we going to find cos A and the sine B? Well, there are actually two different ways to do it. So the first way is to utilize the Pythagorean identity. What is the Pythagorean identity? Well, we did last class. Well, not last class, like 2 classes before, 3 classes before. Cos squared A plus sine squared A is the same as 1. And last class, well, whenever we did that, we proved this identity, right? Like I showed you with the triangles and all of that, and how exactly they derive this identity. So the first way to find cos A and sine B, we can utilize the identity. How exactly do we use this identity to find cos A? This is for cos A, right? Well, last class, no, not last class, whenever we did that, I told you that cos squared A can be rewritten as cos A squared. Same thing with this. Sine squared A is the same as saying sine A squared. Let me just put an equal sign for now, right? We're trying to find cos A, so we're trying to find this. But we have sine A. They gave me a value of sine A. They told me that sine A is minus 8 on 17. So therefore, if I substitute the value of sine A that was given, I would be able to find the value of cos A. So let me just erase this red part. So this is just me substituting the value, right? They already told me that sine A is minus 8 on 17. And we're trying to find the value of cos A. That's the only way we can find this value, right? We need to find what cos A is, and we need to find the value of sine B. So we're trying to find cos A. How do we do that? Well, cos A squared. We are given sine A. Oh my gosh. Okay, anyway. We're trying to find cos A, right? So cos squared A plus, we are given sine A, and sine A is minus 8 on 17 squared. And let's just say this is equal to 1. Now I have an equation where I can find the value of cos A. All I need to do is transpose. Anybody who wasn't here with me, transposing just means to make something the subject of the formula. We want to find the value of cos A, so all we have to do, make this the subject of the formula, right? So from here, it's just basic algebra. Can I erase this yellow part just for now? Or rewrite it after?
Yes, miss, you can erase the yellow part.
Like I said, all we're doing is trying to find this value of cos A, right? Because we need that value of cos A in order to find the exact value of cos A minus B. So, like I said, this is just basic algebra here. So cos A squared. Can anybody tell me what's minus 8 on 17 squared?
Would that be 64 over 289?
289. Anybody does not understand how we got that? Going once, going twice. All right. So like I said, basic algebra, right? We're trying to solve for cosine A. So what do we do next? Cos A squared. That's the 2. Sorry, this thing isn't working. So this would become, on the right-hand side, will be 1 minus 64 on 289. What's the value?
I believe that's 225 over 289.
220. Oh my gosh. Is everybody following so far? Like, am I going too fast?
No, that's fine.
Yeah, miss, you're going good, miss.
Okay. So can anybody tell me if I want to find, so I want cosine A by itself, right? What would I do to get cosine A by itself?
Could you try taking the square root of both sides?
Square root of both sides. Good job. I don't know who's answering me, but woohoo! Yes, good for you. Also, anyways. So, okay, so let me just try. What's the square root of 225 on 289?
Is that 15 over 17?
15 over 17. However, there's one thing you have to note here. When we're finding the square root of a number, I told you, unless told otherwise, you always have to find, so let me just write it here. When finding the square root of a number, it's always plus or minus, right? Plus or minus, unless told otherwise. This right here, when doing questions like these, this is one of the questions where you have to pay attention to which sign you have to choose. Both of these signs are not valid. It can't be plus or minus 15 on 17. And you might be wondering why. If you look back to the beginning of the question, this is where the range comes in. They told you that A is greater than 180, but less than 270. That is very significant for this question, right? It would tell us whether we're taking the positive 15 on 17 or negative 15 on 17. But how exactly do we know which one to take? That's why it was important for me to, show you what quadrants are. So for the people who were with me last class, and anybody who just has any knowledge about quadrants, no. Okay, quadrant. S, no. S, T, A, C. So for the people who were with me last class or anybody who knows about quadrants, this is what it looks like, right? You see the Cartesian plane where you have an X and Y axis. It divides the plane into 4 sections. Those 4 sections are called quadrants. And using those quadrants, we can determine angles, right? That's what we were doing last class. Here, with questions like these, my knowledge of the quadrants would help me to determine whether I'm taking the positive angle or the negative angle. Well, this is not an angle, but the positive or the negative value. So in the quadrant A, all angles are positive. In this one here, called the second quadrant, only sine is positive and tan and cosine are negative. In this quadrant, tan is positive, but sine and cosine are negative. And in this one, cosine is positive, but sine and tan are negative. So let me just label this. So this is 0 degrees. This is 90, 180, 270. And then we'll come all the way back up to 360, right? They told me A is greater than 180, but less than 270. Greater, anyways, greater than 180, but less than 270. So what does that mean? You see that angle A? It's lying in this quadrant here, in the third quadrant. In the third quadrant, tan of whatever angle it is, the value would be positive. But if it's sine or cosine, then the value would be negative. In this case, so we said that A is in the third quadrant, right? Third quadrant, only tan is positive. Cosine and sine are negative. I see cosine of A here. So what does that mean? Since A lies in the third quadrant, and in the third quadrant only tan is positive, we're finding cosine in this case. So cosine has to be negative. Because A lies in the third quadrant, only tan is positive, sine and cosine are negative, and therefore cosine of A has to give me a negative number. Just like if we had sine of A would have given me a positive number, or semi-positive. Sine of A would have also given me a negative number, but tan of A would have given me a positive number. Do you understand that?
Yes, Miss.
That was one person. What about the rest?
Yes, miss.
Okay, one more person. If you don't understand, I'll explain it another way. One more person. You good? Oh no.
Yes, Miss.
Wait. Was that the same person answering? That was kind of sus.
No, miss, I think that was Choi Zhang, miss.
Okay. That was kind of sus. But anyway. So we have our value for cosine A. It's minus 15 on 17, not plus, minus. Oh. No. Anyway, right. So we have cosine of A, but I also told you we need to find the value of sine B. And we can also use that same method to find sine B. In this case, we're still using the Pythagorean identity, but our angle is now B. So the cosine squared B plus sine squared A is the same as, let me A now, B, that's a B, is the same as 1. So before our angle was A, in this case, our angle is B. Now, so we said cosine squared B is the same as saying cos of B squared. Sine squared B is the same as saying sine B squared. We already know the value of cosine B. They told me it's minus 5 on 13. We're trying to find the value of sine B. We know that this would be equal to 1. So like I said, basic algebra, transpose, find the value of sine B. So can you work that out and tell me what's the value of sine B?
Miss, can you repeat the question, please?
Find the value of sine B. And then let me know what you get.
Oh, I have 12 over 13.
12 over 13.
And I believe it's, sorry?
Positive. Positive or negative?
I believe it's positive because angle B is in the first quadrant where sine is positive.
Okay, that's one person. I just want one more answer. Do you
Miss,
agree?
I totally agree. Miss, I totally agree with everything he said. And I honestly hope they can teach us advanced science right after this class.
I don't know what you just said, but okay. Can you repeat what you said, please? Like after you said you agree with what he said.
Miss, this dude, just looking at his profile picture, miss, he's Asian. That means he's smart. I want if he can, like, he got to teach us advanced science after this.
Oh my gosh. I have no comment, okay? Just no comment. Anyways.
All right,
Yeah.
I'll be holding my advanced science class after this.
Sine B, the answer is in fact 12 on 13. And it is positive. Why? Because they told me that the range for B is that B is, what is the range? B is greater than 90 but less than 180. which means it falls in the second quadrant. In the second quadrant, sign is positive. Therefore, if I'm finding sign of B, the value would be positive, right? So yes, that is correct. Good job. Now let us, finish this question. So now that I have the values of cos A and sine B, I can now finish my question. So what we originally had was the double angle formula. So cos A, cos B plus sine A, sine B. So now that I know the values for all of these, all I need to do, substitute the values, and yeah, that's the answer. So it's relatively simple, right? Like once you practice and all that, or maybe you understand it fully now, like I said, it's not really anything too difficult. So we just found out the value of cosine A minus 15 and 17. We were given the value of cos B, which was minus 5 and 13. Plus, we were given the value of sine A, minus 8 and 17. And we found out the value of sine B, and we got 12 and 13. Positive
Miss,
12 and 13.
meeting time about to finish, miss.
Oh my, rejoin after this, okay?
Yes, miss, understood.
All right. And give me this value. When we come back, I want you to tell me the value.